Hi everyone. We're gonna get started in just a second. I'm just letting this run for like 1 or 2 more minutes so people can arrive. So kick back, fill up your water, and we'll get started on lab number 4 at about 2:05. Alright, let's get started here. So for today's discussion, we are going to talk about... I didn't capture the PDF, apparently. That's the YouTube page I am playing video from. Where is... It's not showing up. Hold on. Now are you going to show up? There it is. Okay, so up here, we don't need this. I should be able to minimize that now. Alright, it's not very big on your screen. This is lab number 4. Lab number 4 is more or less... Oops, that's not what I want. Sorry, I maximized it on my screen and it got really big. You can read it now because I can read it. Lab number 4 is more or less just here's some actual data, determine an empirical formula. That's sort of the whole point, so I guess we're done here, right? Now I'll talk about it a little bit. What we're going to do is we're going to give you some data from an experiment. And the gist of the experiment is that we're going to put a powder into this container. Somebody drew this in mouse paint or MS Paint or whatever. And that compound is going to be heated such that the water that's inside it will get removed. When you do that, you'll be able to tell the number of grams of water that are in there and the number of grams of compound. And I'm going to show you more or less how that works on my screen here. So, oh, geez, Steve. I don't know why he has to message me every time right when I start class. God, I wish I could mute that sound. Maybe I can. Hold on. Oh, I could just tell him to be quiet. Okay, so here's what happens here. So in the experiment, we're going to have a container with a lid on it. Okay, so this is my... Yeah, you guys can't hear it because I have audio disabled for stuff, but it's really loud in my ears. So this container is called a crucible. And the crucible has a lid. What this is it's a cheap ceramic object that is just basically something that you can hold material in, but it's very, very heat resistant because it's ceramic. What we're going to do is we're going to put our solid substance that we're going to heat into it. And so this is what we're going to call a hydrate. What a hydrate is a chemical compound that also has water molecules as part of its chemical formula. Now, hydrates tend to be ionic. So what that means is if I had a hydrate like, say, this, so I'm just going to make up one. So MgCl2, that's not a hydrate because there's no water. But maybe I have this and there are two water molecules in the formula unit. So inside the crystal lattice, water molecules are also bound. And so what we do is we indicate that by writing this dot and then however many water molecules are bound to it. This is the hydrate part. If instead of it being a hydrate, I got rid of this part, then what we call it is anhydrous. So a hydrate has water and an anhydrous compound does not have water in it. Okay. What we're going to do is we're going to do this process. We're going to start with a hydrate. Then we're going to heat it. When you heat it, all of the H2O will boil away. And what will be left is the anhydrous compound. Now, generally speaking, when you have a compound that is a hydrate, it will have a different color to it than if it is anhydrous. In the case of the substance that you're going to be working with on this experiment that you're going to see in a video, the copper compound that we use starts off kind of bluish green, and when you're done, it's tan. Other hydrates exist where like it starts pale blue and then it's white. A popular cobalt hydrate starts off blue, or I'm sorry, it starts off pink when it's a hydrate, and when you finish heating it, it's blue. There's all sorts of different crazy combinations there, and I could talk about why the colors appear and how that happens all day, but it's well beyond the scope of this class. It's actually what my degree is in. So I could talk about transition metals and d orbitals till the cows come home, but let's not do that. So conceptually, this is how this works. You have a crucible, you put stuff in it, you heat it, the water goes away, it now weighs less because the water is not inside, and then you subtract. So how does the math work here? So let's see here. I wish I had 3 colors, but I don't. So I'm going to go after heating and before heating. And we're going to describe what is in all of these things. So the first thing that we have is the crucible. And the crucible and the lid, because the lid's part of it, is present both before and after. If it's not present after, you probably broke it and you need to try again. Not that you're actually doing this experiment, but this is the lecture I'd be giving you if we were in lab. What else is also present? Well, we also have the hydrate. Well, actually, let me write it this way. Let's not write it like hydrate. What I will actually call it is I will call it the compound. So this would be like the MgCl2, for example. And that's going to be there in both before heating and after as well. after heating, the water is gone. So this is the only change here. So this is going to be the H2O from the hydrate. That's present before we heat. But after heating, it will be gone. So if I take these numbers, so like I know the masses of all of these things and sum them together, and then I know the masses of these two things after I've done heating them and sum those together, I could then do subtraction. And if I subtract, these cancel because they're the same, and these cancel because they're the same, leaving only this. So what you would do in the laboratory is very simple. You'd weigh your crucible and your lid. You'd put the blue stuff in there, and you'd weigh it. Because before heating it, the stuff that you put in would be this right here. Then you would heat it, and you would weigh it again afterward, and what you would see inside the container, which would no longer be blue, it would be brown, would be that right there. Then you do this process and you subtract, and you get the mass of water. Now, how do you get the mass of the stuff that you put in there? Well, you just weigh the crucible before you put anything in, and then you weigh the crucible after you've put stuff in, and then you do the subtraction with the same principle. You would cancel out the crucible and lid, and the difference would be what you added. It's kind of like if you put a cup of water on a balance, and you say, oh, I want to weigh what's in the cup. Well, you could weigh the cup with the water, then dump the cup's contents out into the sink, and weigh the cup again, and the difference would be what you dumped out. Provided that, like, you cleaned it out completely. Generally speaking, you should weigh before you do anything to it, just because you can ensure that your container is empty. All right, so that's how you are going to collect the mass data for this experiment, is you're going to follow this sort of process. So when I go back to this PDF here, you could read this discussion, and what it's eventually going to do is link you to this video. And let me click on this video really quickly. And that's going to not pop up in a window capture because I don't have it. So let's see what this gets me. That's not super useful. Let's get rid of all these ads. So you're going to see a video here when you click on that link that I found from another college. And the video is going to show you what you would have been doing in the laboratory if you were actually doing the experiment. It's also going to include number data for you. You're going to be writing down some of the numbers that you observe as the directions tell you, and putting that in. Let me move this up. Oops, that didn't actually shift. I think I have to hold Control. There we go. And putting numbers in the data table that you have. So I'm just scrolling down here. And there you go. So there's this data table here. Oh, sorry, this is a sample experiment. This is the video where you're going to do the table and use their data. Okay? So you're going to watch the video and not just watch it to understand the process, but you're also going to take data from the video here. Let me put the video back up. It's blank because it's in the background. That's the wrong video. Hold on. That's satisfactory. I want this one. There we go. So you're going to collect some data from this, and then they're going to do the experiment. They're going to talk about what to do. And I'm just tabbing through here. Here is the Bunsen burner process. There's what the compound looks like beforehand, and so on and so forth. So you're going to watch this video and answer the questions and fill in the data table, and then complete all of the numbers. Now, you'll see that there are a lot of numbers, and a lot of these numbers depend on previous numbers, so be really careful that you know what you're solving for. If you wrote down the wrong mass of the crucible to start, you're in trouble because everything else depends on that. And you'll get all of those answers wrong. So make sure that you are very carefully determining each entry. Now, for what it's worth, you are only going to be recording 3 numbers from the video. And the 3 numbers that you're going to be recording, let's go back to here. I've sort of shown them on the screen here. Well, conceptually I have, but... So the 3 numbers that you're going to be recording. So you're going to record the mass of the empty crucible. That's important because you need to know the container's mass. The next one you're going to write down is the mass of the crucible and the stuff before you heat it. And then the third one is after you heat it. Now, be careful because the video might, and I'm saying might because I don't remember what specifically the video did because I wrote this 12 weeks ago. They might show you several masses for after heating, and you want the one that is when the heating is complete, okay? What I mean by that is, if we go back up here to my diagram, as I heat this, more and more H2O comes off. At some point, all the H2O is gone. But if you were to stop heating before you removed all the H2O, you'd get a number that was artificially high. And the way that that is checked is that you weigh it after you think you're done heating, you heat it some more, and then you weigh it again. And if those masses are the same, nothing has changed. That must be because there's no more water. Okay? So if there are multiple steps, so careful, maybe checked several times. And that looks a lot like the word cheeked, which I don't understand what context that is in. So maybe checked several times. There you go. So just be mindful of that. The video may do that. Other than that, what's going to happen in this lab documentation is you're going to do this process a few times. So the first one, I have created some random numbers. They're not random. I actually calculated them so that it works out to be solvable. And you're going to determine the formula based on this. So just like any empirical formula problem like we did yesterday, you are going to have to figure out the mass of each of the parts, turn those into moles, and then create the mole-to-mole ratio, and then turn that pseudo-formula into an actual formula. Now, the difference here that you're going to find is that instead of doing it on a per-element basis, you're going to do it on a compound and hydrate basis so you can get X here. In other words, what that means is that your formula, if the compound is A and the hydrate is B, you're going to solve for the moles of A and the moles of B. And you're going to notice that this one's always going to be the smaller one. And this one is going to be larger by some factor X. And your job is to solve for X. Okay? So it's a different application of empirical formulas, but you do the exact same math. Just be careful that you don't break this down on a element by element basis, because that's not going to help you. That's going to just make more work for you. So treat the compound, the ionic compound itself, as if it were just just call it A or Q or whatever. And then the water is the other part, and solve for those parts in terms of their moles. And as far as I can really say, so you do it again, and then you do a bunch of analysis questions, which you do it again, and again, and again. because I've graded Lab 2, I can say this pretty safely. A lot of people were not very careful with sig figs. Be very careful with sig figs in this lab, just like you would be with anything in numbers. I do realize that Canvas doesn't really give you good practice with that, because I tell you, do this number of sig figs, and either you do it or you don't do it, and Canvas ignores it. But on the labs, I do pay attention to that. So make sure that you are putting the correct number of sig figs in your data table. What else can we talk about here? Where is my teaching window? There it is. Everybody should know by now where to access the lab materials. So if you go to Canvas and you go to Modules, and you click on Lab Worksheet number 4, that should pop up right away. My window capture is not... That's the wrong window capture. There we go. There we go. And so here's what lab number 4 looks like. It's just going to be a bunch of empty fields that you're going to be typing in numbers into. You'll notice that I have entered all the units on the side here. So this is just to give you a hint of what you should be typing in. What that means is that you do not want to put units in these cells. Okay. Also, importantly, I've put some notes over here about formatting. If you know Excel commands, or Google Sheets commands, they're universal pretty much, you may use those commands to perform formulas. What that means is if you say, oh, the mass of the sample must be these two numbers manipulated in some way. Let's suppose that you wanted to divide them. Obviously, that's not what you're supposed to do, but I'll use that as an example. So if you wanted to divide these two numbers, you would type equal, and then you could just type in the cell name. So this is cell F14, so I could go F14, which will then read that number. Or what I could do is I could just click on them. So I'm going to say this, and hit the divided by button, this, and then I hit enter, and it will spit out a number. It will spit out way too many sig figs, though. So then what you got to do is up here, you can see these buttons up here. You can decrease the number of decimal places as appropriate. Okay. Now, obviously, you're not going to divide these numbers because you don't divide to get a mass. So I'm going to erase that. But that's how you can do some very simple commands in Excel. Some other cells will already have me having typed something in here. So, like, when you get the ratio of water to whatever, don't over-type what I have. Type something else in here. So this might be like 6:1. I don't know. I'm just typing in numbers as an example. All right. I can't really think of anything else to do. Make sure that for any question that I ask you to explain how you arrived at your answer, that you do that. But otherwise, that's pretty much it. This is more or less just, hey, we did this in lecture yesterday, now do a lab on it. And if I hadn't done all of the lecture from yesterday, I would probably spend more time explaining it. But I feel like that's pretty much it. So, yep. If you have any questions, let me know in the chat. Actually, we'll just get rid of this. Boop. Now, I don't see anybody in here accessing this file, so I don't know if there are issues with it. Let me know if worksheet number 4 doesn't pop up or something. Normally, I see like 30 billion people accessing the file because I'm doing that during the lab. But that said, there are also only 12 students watching this video currently, so it might just be that, oh, we've already done that, or whatever. So make sure you can access the file. let me know if something comes up. Okay. I'm going to open this up for questions for review. Again, I realize there aren't that many students here. You have a question about sig figs. What's up? Go ahead and type anything you need in the chat, and we'll go over it. Let me just clear all of this. File works fine. Okay, that's good. That's what I want to hear. That means I didn't do something dumb, which with Google and because Google changes everything every like 74 minutes. Like they moved my button mid-quarter to put videos into playlists, and I was like, where the heck do I put this video into a playlist anymore? I had to find that. They had moved it like 30 centimeters to the left for some reason. So it wasn't where I expected it, and I spent like 20 minutes trying to find it, and of course trying to Google anything about how Google works is impossible. I don't mean to disparage the people that are letting me stream in my education related content for free, but sometimes it's a fucking shit show. So are there any changes to Sig Fig rules? Nope. Everything is exactly the same as we discussed it during week 2. I'm going to say 2. So all the addition rules are the same. All the multiplication rules are the same. If you change operations, do your sig figs before you change operations. But that stuff is good all the way up until 162 when you get to logarithms. When you use the log function, it has a new sig fig rule. I don't know if other instructors teach it to you. I talk about it, and I don't expect you to know it. But for every mathematical operation you do, it has its own sig fig rule. So, like, if you take the sine of something, so like sine of 90 degrees, which is, I don't know, what is it, 1. There are sig fig rules for that. Sorry, I operate in radians, so pi over 2, I would have been like, oh, it's 1. Yeah, for molar masses, when you are getting those numbers, you want at least 4. If you can get more off of your periodic table, then sure, get as many as you want. The real thing that you want to note is that if you're doing something like this, like, okay, let's say I have this many grams of sodium chloride, and I want to turn it into moles. What you want is you want this to be the limiting factor. You don't want this one. So if I went to the periodic table and I said, oh, NaCl is 58.44 or something like that, so I wrote this, that's going to ruin your precision. Whereas if I do that, is it 58.44? I'm doing iron again, probably. I'm trying to do this from memory. Whatever number it ends up being. So if you put in 4 sig figs here, then this is going to limit your sig figs. And when you get to your answer and you type it into Canvas, Canvas is not going to mark you wrong. You're not going to fall outside the margin of error because when I did the calculation, I based it on these sig figs. But if I did it in a different way, so let's suppose that I did this. So if I did that, if you use fewer than 4 sig figs here, then this becomes your limit, and you don't want that. So in reality, you should always get as many sig figs as you can, but that's not what I wanted. I don't know how... And of course I can't undo it because Photoshop. In reality, you should get as many sig figs as you can, but for our purposes, 4 is usually going to be good enough. I just had a thought. Maybe it is. Maybe it is undoing. Interesting. Let me try something. Yeah, look at that. Okay. I'm learning something about my Photoshop here. That it actually is updating random stuff. Let me get to these questions one at a time. So, what is a formula unit? A formula unit is like a molecule for an ionic compound. So, for something like this, the formula unit is how many MgCl2s do you have? Now, remember that for ionic compounds, they exist in a lattice. And I got to change colors here to fill this in. This is what my ionic compound would look like in reality. And a formula unit of MgCl2 would just be that part right there. It's like a molecule of ionic compound, but with the realization that molecules don't exist in ionic compounds. Whereas if I had something like, say, this, H2O, H2O exists as molecules, and those molecules are independent of each other. Sorry, Hannah, I'm confused by your question. Is it the particles in the chart you gave us? Oh, yeah. So on that moles, particles grams chart, formula units is this one. So this is formula units. This is also molecules or atoms. Those all go in here. Sorry, it took me a second to realize what you're talking about. In the A times XB thing, what does the X stand for again? For that, that's going to be some coefficient, some number for the formula. So if you figure out the number of moles of A, so let's suppose that I ended up with like this. So if I determined this, what I would then do is divide by the smallest number, just like I was doing for my molar ratios yesterday in the lecture. And so I would get that. And then my formula would just be this. So you're trying to solve for the formula, and what you're trying to do is figure out how many water molecules are in there. When determining chemical formulas, how do we calculate the final charge? What do you mean by final charge? Because the charge of an ionic compound, when it's like complete, all the ions are there, should always be 0. Because if I had a compound like, say, this, and it had charge on it, what it would do is it would attract something else that was negative to it and change its formula. So the formula would keep changing until the charge was 0. So I'm not sure what your question is. Yeah, I can do that. But yeah, if Gabe, if you can let me know like more specific on your question, happy to answer it. I just don't quite know the context of your question here. Let me make up something for formula units. So let's suppose that I have, I don't know, 3.58 times 10 to the 24 formula units of, I don't want to pick NaCl because that's really boring. Let's do sodium hydroxide. So let's suppose that I have this many formula units, and I want to figure out its mass in grams. So here's my general process of what I would do. And so I would say, okay, start with what you know. And then I would convert formula units into moles. And then I would convert moles into grams. Oh, I see. Yeah, so there are periods on my sentences, and those periods are on the norm where they would normally go. But after the subscripts, they do kind of look like charges. All right. I got my problem set up. I'm going to fill in the numbers in a different color. So in 1 mole, how many formula units are there? Well, in 1 mole, how many of anything is there? It's always the same amount. It's Avogadro's number. And then in 1 mole, how many grams of this are there? Well, that's the periodic table. And this one I actually have memorized. So I'm just going to write in the answer. It's 40. For some reason, sodium hydroxide lands on almost exactly 40. It's going to be like 200, but I don't actually know what the answer is. So, times 40. So when I punch it all in the calculator, I get 237.79. So that would be 238 grams of sodium hydroxide. So that's how you use formula units. You do it exactly the same way as if this word formula units was instead atoms or molecules. Same process. It's just that conceptually, formula units are just the repeating thing that you find in an ionic compound because a molecule of an ionic compound doesn't exist. They exist in lattices or as independent individual ions. Yep, you got it. I gotta keep watch on the time here because I mean we're close enough to our break here. What I'll do, I'm gonna put the break timer up since it seems like there's a little lull in the questions. I'm gonna put oops, that's the title card. Let me put this up here. I'll collect questions for 10 minutes, and if nobody has any questions, we'll just call it a day. So let me go back to the satisfactory OST. That's what music I'm going to have to do tomorrow. I'm going to do Factorio. If you like games that involve you, like, making stuff. For example, if you're an engineer, play Factorio and play Satisfactory. They're amazing. I'm not either of those things, but I still love these games. So, turn the music back on, and I'll see you in 10 minutes. Put any questions you got in the chat, and I'll be happy to answer them when our break's over. See you in a bit. Okay, so since we're talking about Satisfactory, I feel like I should load the game if I can find it in... Oh, update queued. No, don't do that. No. Maybe it'll finish updating before the break is over. Let me see how big the update is. 137 megabytes. Okay, that's nothing. But since we have like 5 minutes here, what I think I will do is I will try and capture it, and I'll just run around my base so people can see for fun. Is the first compound just FeCl3? So it's FeCl3, and it will have water associated with it? Oh, sorry, is the anhydrous compound just FeCl3? Yes, it is. In fact, let me type that in there. Yep. Just so you have it in the chat log. Sorry, I completely confused myself. Alright, it says done in 20 seconds. Now that it's done doing whatever check thing it was trying to do. Oh, now it's 30 seconds. I have decent internet, so I'm surprised this is taking this long. Oh, what is it doing? Oops, I missed the timer. Okay, so I'm just gonna let this run in the background. Like I'm trying to update Satisfactory because there are people that are interested in it. I kind of also would not mind showing it off. If there are other questions, I'm just gonna leave it on the screen for a second. If there are other questions, I can happily answer them. There is a quiz due tomorrow. Again, soft deadline. This experiment will be also due. It's not a week from Thursday because that's Thanksgiving. So what date did I put this on? I believe it was the 4th. So you get 2 weeks to do this assignment. Let me quickly look up the due date because that's in the syllabus. And then I will type that at the bottom so you can see it. Lab worksheet number 4 due. Do I have a typo on my... Oh, no, I just read... I can't calendar correctly. Okay, so... Where is announcement? There it is. Okay. So quiz number 7's due then. Lab number 4 due Thursday, 3 December. All right. Yes, it is. So if you turn in anything and Canvas flags it as late, I ignore it. The only thing I don't ignore on Canvas is when I toggle it to closed. So if you get a closed error and you try and turn something in, it will tell you, like, hey, you can't submit this. The assignment is closed. Then you have to email me, and then I actually flag it as late or NQA or whatever. Generally speaking, I don't accept late assignments. If you use your NQA coupon, then I will. Is the lab really tedious? How long does it take? That's kind of an unfair question for me because to me all the labs are tedious. Like I do them really quickly, but the whole point is to do it like 6 times over and over and over until you understand how to do it. So, sure, I guess it's tedious. Question 2 on the lab. It asks what X represents. What does X represent? Now, I don't really want to just tell you that because so it is explained in the reading. Like I'm looking at the answer right now in the PDF, so I'm gonna leave you to read that. It is on page number 1, so do read the PDF there for questions like that. You can keep asking questions. You're gonna hear some audio in the background. Hopefully this works. Let's see here. Okay. But yeah, keep asking me questions. Let me hit load here. Your screen's gonna just go. This is mostly for Kyle because Kyle wanted to see this. I can still see your questions, by the way. I have no idea if this is updating. Let's see here. Let me see if this works here. It's not updating on my screen, so I don't know if that is working. I don't want full screen. I don't know if I can get it to work. Is it working now? No? Okay. If I do that... No, okay. Yeah, I tried. I don't know. I'd have to sit down and actually, like, figure out what is going on here. To find the moles of anhydrous compound remaining, take the you just take the grams of the anhydrous. So after it's dry, and then you just turn it into moles. Let me try deleting this. Remove. Well, that's definitely not what I want. I don't know why this won't capture. It should be working, but it's not. Well, that's not what I want either. Oh well. Doesn't seem to be working. So, any other questions that you might have? Just let me know. And I mean, I don't have much else to do here, and we'll probably call it a lecture in 5 or so minutes if nobody has any other questions. So if you do 1.00 minus 0.367, what will happen there is you actually get this as your answer. 0.63. And the reason for that is 1.00 goes to the hundredths place, whereas the other numbers go to the thousandths place. So if you do the subtraction, you have to rely on places. Okay, this might actually work now. No, now it's showing me the title screen. I don't know what's going on. I could capture one frame, but that's it. I might have to play with this and just try it after class one day. I mean, I could take a screenshot of what I've made, so... I forgot how to run in this game. I haven't played it for a while. So I could do this, so print screen. And then... It's a very slow way to play the game, so then I could paste it in here. There we go. That's what I'm looking at right now. So I've made this. It has taken me... How many hours have I played this game for? Let's see. 97. So 97 hours is how long I've put in the Satisfactory. Which is like a drop in the bucket. And I'm not very far, but it's fun. So yeah, that was a really long segue to say like, hey, the music that I'm playing for today's game is a really fun game, and if you're an engineer, you should check it out. So we'll just get rid of that. And of course I can't do that because Photoshop. Ah, there we go. On the wrong layer, aren't I? Other questions about the lab, about pretty much anything, really. We'll call it a day if nobody else has any more questions after this point. I gotta give people a chance to type if they are typing, so. Alright, so what I'm gonna do is yesterday I mentioned course evaluations. I needed an extra day because apparently it needed to do something before I could hit release. I'm going to go into the course eval thing, get the link that you then go to. You should be able to log into course evaluations using your student login, and then you have until, I want to say, the last day of class to do it. There will be a date on my announcement that's going to come out, but you will see that announcement pretty shortly. In fact, it will probably appear down here where I'm typing right now. There will be an announcement regarding course evaluations on tomorrow's lecture because I will have done that. So look for that. Remember, it is extra credit. And thanks for watching. I will see everybody tomorrow so we continue on to chapter... What are we on? 14? 14, something like that. I will see you then.